You turned off the light, simple enough. You reached for the switch, or tapped the lamp, or closed the laptop, and the light that was filling the room a moment ago ceased. The darkness arrived the way darkness always arrives, not gradually, not with ceremony, just immediately, completely, as though the light had simply decided to stop being a thing, and you gave it no thought at all. You have done this 10,000 times. The light stops, the room goes dark. But let me ask you something. Where did the light go? Not poetically, not as a metaphor, as a physics question asked with the same seriousness you would bring to asking where a rock goes when you drop it. The photons that were filling your room a moment ago, billions of them bouncing from surface to surface, arriving at your retina, generating your entire visual experience of the room. What happened to them? Did they cease to exist? Did they transform into something else? Can a photon die? And if it can, what does death mean for something that has no mass, no internal structure, no clock, no experience of time? Something that is, as far as physics can determine, a fundamental and indivisible feature of reality. Follow this question honestly and you end up somewhere that connects the death of a photon in your living room to the birth of matter in the early universe, to the heat death of everything, and to a 50-year-old unsolved problem about the nature of information that keeps some of the best physicists alive awake at night. What happens when light dies? The answer is going to reach much further than the question. Now let's be generous to the intuitive answer because it is partially right. Light is energy. Energy is conserved, one of the most tested, most foundational principles in all of physics. Therefore, when a photon disappears, its energy cannot simply vanish. It goes somewhere. The photon is absorbed by an atom in the wall. The atom's electrons jump to higher energy states. The energy is re-emitted as heat, as infrared radiation, as the random thermal vibration of molecules. The organized directional energy of visible light becomes disorganized thermal energy. The photon is gone, but the energy persists, degraded, scattered, but conserved. You might say light doesn't die, it transforms. Nothing is lost. The energy keeps going in different forms forever. And that is a genuinely good answer to a slightly different question. Let's check what it misses when you ask the question more carefully. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. We are going to take things apart and see what makes them tick. Let's find things out together. Here is the first thing to establish with precision. A photon is not a small version of a light wave. A photon is the quantum of the electromagnetic field, the smallest possible unit of electromagnetic energy at a given frequency. It is not divisible. It does not have a surface or an interior. It has energy, momentum, polarization, and frequency, and that is the complete list of its properties. It has no rest mass, which means it cannot slow down. In vacuum, it travels at exactly the speed of light, always, without exception, because it has no alternative. It does not experience time. From the photon's own perspective, if we can stretch the phrase that far, it is emitted and absorbed in the same instant, because relativistic time dilation at the speed of light means no time passes between creation and destruction. The photon does not travel through time. It exists at both ends of its journey simultaneously, in some sense that is precise mathematically and deeply strange conceptually. Here is the analogy that makes this land. Imagine you send a letter, and by the time the letter arrives at its destination, every moment between sending and arrival has been compressed to zero. The letter does not experience the journey. For the letter, there is no journey, only departure and arrival as a single event. That is a photon. The billion years it spent crossing intergalactic space before entering your eye, from the photon's frame of reference, that did not happen. The emission and absorption were simultaneous. Do you see what happens? Now here is where the death of a photon gets genuinely strange. When a photon is absorbed by an atom, what precisely occurs? The photon ceases to exist as a photon. Its energy is transferred to the atom's electron, which jumps to a higher energy level. The photon is not transformed into something else the way water transforms into steam. It is annihilated. It stops existing as a distinct quantum object. The energy it carried is now part of a different quantum system, the excited electron. But the photon itself is simply gone. This is not like the death of a complex organism where the components scatter and recombine. A photon has no components. When it is absorbed, there is no remainder, no residue, no ghost. The quantum object that was the photon ceases to be a quantum object. The energy moves on. The photon does not. Now let's add the layer that makes this existentially uncomfortable. Every photon that has ever been absorbed has carried information. The frequency encodes how much energy it carried and where it came from. The polarization encodes something about the electromagnetic environment that produced it. The timing and direction encode the geometry of its origin. When a photon from a star 800 light years away enters your eye, it is carrying information about the surface temperature of that star, about the magnetic fields threading its atmosphere, about nuclear processes occurring in its interior. That information has crossed 800 light years to reach you. When the photon is absorbed by your retina and ceases to exist, what happens to the information it carried? This is the question. And the answer is one of the deepest unresolved problems in theoretical physics. Now I want to take this deeper, because this is not just a question about individual photons. It is a question about the fundamental nature of reality. Quantum mechanics has a rule, and this is not a peripheral rule, this is load-bearing, this is structural, that information is conserved. The technical statement is that quantum mechanical evolution is unitary, which means the information content of a quantum system is preserved through time, even as the system changes. If you know the complete quantum state of a system now, you can, in principle, calculate its complete quantum state at any past or future time. Information is never created or destroyed. It is transformed and scrambled and made practically inaccessible, but it is never erased. This principle is why the black hole information paradox is a crisis. When matter falls into a black hole, and the black hole eventually evaporates via Hawking radiation, the radiation appears to carry no information about what fell in. The information appears to be destroyed. But quantum mechanics says information cannot be destroyed. Something has to give. And here is the connection to the death of your photon in the living room. When the photon is absorbed and ceases to exist, its information, its frequency, polarization, phase, direction, is transferred to the absorbing atom and then, through subsequent collisions and re-emissions, scattered into the thermal motion of the wall's molecules. In principle, the information is still there, encoded in the incredibly complex quantum state of billions of molecules vibrating in slightly different ways. In practice, it is irretrievably scrambled, lost not because it was erased, but because the scrambling is so extreme that recovering it would require measuring the exact quantum state of every molecule in the wall simultaneously. Your living room wall is a library where every book has been shredded and mixed together and scattered. And the books are written in a language that requires quantum measurements to read, and you have no quantum measuring device, and the shredding never stops. This is the part that keeps me up at night, because here is the full implication. Every photon that has ever been absorbed anywhere in the universe has scattered its information into the thermal noise of whatever absorbed it. The light from the first stars, the photons that carried the first images of the first structures in the early universe, absorbed billions of years ago, their information scrambled into the heat of ancient gas clouds, inaccessible forever in any practical sense. The universe is performing at every moment an irreversible computation, taking organized information and distributing it into complexity so extreme it can never be recovered. This is the same process as entropy increase. The death of photons is entropy in action at the quantum level, and the endpoint, the heat death of the universe, is the state where all photons have been absorbed and re-emitted so many times, and the universe has expanded and cooled so much that the remaining photons are of such low energy, such long wavelength, so spread out across such vast space, that they carry essentially no usable information and can do essentially no work. The universe ends not with an explosion, but with the last photon redshifted into silence. Bring this back to the light in your room right now. The photons leaving your lamp or your screen are carrying energy that originated in the sun. Nuclear fusion converting hydrogen to helium, releasing gamma rays that bounced around inside the sun for 100,000 years before reaching the surface, emerging as visible light, traveling 8 minutes to Earth, generating electricity in a solar panel or being stored in fossil fuels over geological time and then burned in a power station. The photon entering your eye is the final step in a chain of energy transformation that began in a nuclear reaction 93 million miles away millions of years ago. And when it hits your retina and ceases to exist as a photon, that chain ends. The energy scatters, the information scrambles, and somewhere in the incredibly complex quantum state of the molecules in your eye, a record of that photon's journey is encoded in a form that nothing in the universe will ever read. Every moment of vision is a funeral. But here is where I land when I follow this all the way through. The photon does not experience its death. It does not experience anything, including its own existence. It has no clock, no duration, no interval between emission and absorption. What dies when a photon dies is not the energy which moves on. It is the organization, the specific, structured, information-carrying configuration that made that photon different from every other photon. That ceases. And that cessation is what entropy is, at the most fundamental level. It is the universe's tendency to take specific, structured, improbable configurations and move them toward general, unstructured, probable ones. You are, as long as you are alive, temporarily reversing that tendency locally. Your brain is taking the scrambled information of photons arriving at your retina and building from it an organized, structured, meaningful experience of the world. You are reading the library before the shredding completes. You are extracting meaning from light before it dies. Every moment you spend seeing is a moment you are racing entropy. Every photon that reaches you carries a message from its source across whatever distance separates you. And the moment it arrives, the moment it gives you what it carries, it ceases to be. Light does not die for nothing. It dies in the act of being received. And reception, it turns out, is what light was always for. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.